यस हेलो एवरीवन। सर आ जाइए।
Okay.
आपके बिना स्टूडेंट मेरे को स्टार्ट नहीं करने देंगे।
अरे नहीं. So guys, everybody a very warm welcome. Okay, so two big subjects, that is 10th of materials and fluid mechanics marathon, have been completed. And guys, we tried our best to make the best content, the best video for you, and I hope that in our intentions, in our whatever the goal we have set, we have achieved something and students got benefited. As we promised yesterday, that we'll be coming with SOM quiz that was available on the app. And now we also promised that we'll be coming with SOM live practice session. So guys, from the morning, guys, let me tell you guys, in last 36 or 48 hours, me and Dheeraj sir both have slept only for, 5 to 6 hours. Because guys, apart from you two, we have other classes, other meetings as well. Okay, so just at 11 p.m. we have finished with our vision batches, and now we are here for the YouTube. And let me tell you guys, after this session also in the night around 1:30 or whatever time, we'll be recording a video for the bark as well. Okay, so everything for you guys. And once again guys, a very warm welcome to all of you. मैंने ज़्यादा बोल दिया यार, अब आप बोलो कुछ.
So guys, now we are starting the practice session, and after that I would like to tell you कि from tomorrow once again the next marathon would be ready. So for mechanical tomorrow production would be starting. As I already told you, production we are going to do in the part because 12 hours are not enough for production. Production need more than 20 hours. Okay, so that is why we are doing production in parts, but I am promising you each and every part would be covered in detail, from metal casting to metal welding and everything. Similarly, tomorrow environment is there for civil. So guys, be ready. And this session is common for both mechanical and civil, as some students are asking. So we would be having 20 plus questions today, and we would be solving in front of you, and you also need to solve with us so that you get to know whatever you learned yesterday. Are you able to apply those things or not? Okay, and tomorrow the next subject would be ready. Okay, and every day we are going to have like that. And after 20th also a wonderful plan is ready for you for engineering mathematics and all. So be ready for that. Okay, yes.
Okay guys, like the video and share with all aspirants guys. It is 23:52 and मेरे को लगता है सर 12 बजे और बच्चे आएंगे क्योंकि वो डाटा आ जाएगा ना उनका.
Yes sir.
Okay, so guys, we'll be solving 20 plus questions. Okay, the questions will be of all chapters. Yes, from deflection there will be some more questions as compared to other, and we have selected those 20 questions such that the variety of topics can be completed. Yes, Swamik, it is available there.
It is available there, and guys, don't worry. So we will see questions, and if after this this session, if anybody wants ki sir, still I have some doubt in some of the topic, then you can tell us on the Telegram channel. If required for that particular chapter, we will once again come. Don't worry, because we have enough time for that, and we are here just for your ranks. Okay, so just give your 100%, and along with our 200%, make your selection confirm. So sir, let's start then.
करो सर, स्टार्ट करिए.
सर क्वेश्चंस आप पहले स्टार्ट करेंगे. पहले
आप पहले कीजिए, तब तक मैं फर्दर बना लेता हूँ अगले मेरे वाले क्वेश्चंस के.
Okay guys, so we are starting. Okay, so guys, this you know about Abhinav sir, the legend. Next, this session is going on. We are moving further. You already know, from 9th of January, we have started this marathon series. This is the schedule. Once again, I am telling you fastly that tomorrow we have casting, welding, metal forming and environment here. Okay, here in metal forming, we would be having sheet metal operation part tomorrow. And the bulk metal forming will be there with material science.
Soil का बताइए सर.
So soil is also there on 12th of January.
Interesting questions this time.
Yes,
मतलब टाइम was concept plus question, but
Yes.
question बहुत खतरनाक वाले होंगे.
इस बार सर ने बोला कुछ क्वेश्चंस भी होंगे खतरनाक वाले और नए होंगे. And I am also promising tomorrow questions will be there with the theory part of this topic, because production we have to keep some numericals so that session would become more interesting, because numericals are coming in gate. So this is we have already discussed. Now we are talking about Telegram channel, civil by Abhinav sir, mechanical by Dheeraj Sardana, where you will be getting all the PDF stuff, handwritten notes. Now moving further guys. Now moving further, now my dear, as I already told you, if you want one-to-one counseling from our counselor about any of the exam, then my dear, there is a link given. You can just click onto it and fill the Google form. Okay, they will call you, they will contact you. So next we are moving further guys. Just wait. This is about soil mechanics, casting, welding, and this is going to be day after tomorrow. This is tomorrow. And now we will be starting, I feel these are Abhinav sir's question. My question will be starting from here. Okay, first let us solve this question. This question is a very much of that type which kind of questions are coming in gate. Bars in series, bars in parallel questions are coming in gate. So guys, you can see this question in the arrangement as shown in the figure. The stepped steel bar ABC is loaded by load P. The material has a Young's modulus of 200 GPa and two portions ABBC have the area of cross section 1 and 2 centimeter square respectively. The magnitude of the load P required to fill up the gap of 0.72 mm. So they are asking you the value of P. Yes, Shubham, good evening. So guys, we have taken the questions from all the topics. 1 to 2 question would be like that which you have seen before. Then you will be having some new questions also. So a good mixture we are having. Okay, जिससे starting में खतरनाक question दिखा के डराएंगे नहीं. Okay, we will slowly improve the level. Okay, so what would be the answer for this if you want to calculate? Assume this bar 1, this bar 2, this load P is acting like that, and you need to find out delta 1 plus delta 2 is given, that is 0.75, because load is just filling the gap, and you need to find out the value of P. That is the question in short. I feel everybody would be solving. Arvind is saying answer is 15. What about others? This class is for both mechanical and civil, guys. For both mechanical and civil, because strength of material is common. From tomorrow onwards, different subjects will be starting for different branches. Till today, everything is in common. From tomorrow onwards, we would be having different session for different branches. Okay, so just try to solve it. You can see this is member 1, this is member 2. If you would be taking a section here to apply the method of section like this, then this is section 1, this is section 2. You know, it is the bars in series case. In series, deformations are directly adding up. So we can write delta 1 as equals to P1 L1 upon A1 E1. Okay, and if you are going to say, they have already given that E is same for everyone. Area they have given 1 centimeter square and 2 centimeter square. Length is given as 1 meter and 1 meter. So you can see delta 2. Delta 2 will be P2 L2 upon A2 E2. So my dear, the point is, when we are going to find out P1, P2 using method of section, there everything is present in the question. So I would be taking a section here. You can see, if you take this section to the right hand side, you can see you will be finding this P force is there. Okay, so for this first section, we are having P force away from the section, means tensile. So you can see here P1 is going to be P. Here generally students are making the mistake. When you are going to talk about the second section, to the right hand side there is no force. So my dear, it means P2 is going to be 0. Here generally students do this mistake. They take P2 also P. So just avoid that kind of mistake. For that only this question is there. So now when you will be putting this value, delta 2 is straight away 0. You just need to put P L upon A E. That is A1. E and L, they are constant. They are equal. You would be putting it to be 0.75 mm. You know the value of L, you know the value of A1, you know the value of E. When you will be putting this, you would be getting, guys, P to be 15 kilonewton. In many of the books, the answer is given 10, which is wrong. Okay, so when you will be solving this, P you need to find out. Length is 1 meter. I am making it 1000 mm. Divided by area is given as 1 centimeter square. So 1 into 10 to the power, you can say 2. Because we are going to convert it into mm, into this is given in GPa, 200 GPa, so 200 into 10 to the power 3. This becomes Newton per mm square. Now, it is equals to 0.75 mm. This will give you P is equals to 15 kilonewton. Okay. So 15 kilonewton B is the right answer for this question. I feel everybody understood this. Shall we move on? Very good, Sumit. Very good, Shreyas. I am happy to see there are some students now who have attended yesterday complete session, today complete session. I was watching when Chandra sir was taking, the 12th hour were going on, and Shreyas was doing some message, Sumit was doing some message. So I am happy to see that you guys have attended yesterday, today, still you are present. Yes, Fanendra was there. Kunal was there. Yes, sir. Sophia, yes. TPM. Yes, sir. They all were there tomorrow and today. And I know tomorrow they will also be there. Yes, Badri is also there. So guys, now the second question. Okay, let me have one question from stress strain diagram. This question you may be feeling slightly of different type. So for this question, I will be giving you some help because yesterday I taught you stress strain diagram for around 2 hours. Okay, so that is the numerical from that. A sample of a metal is tested in tension and it is found that there is a strain of 0.0080 at a corresponding stress of 450 Newton per mm square. On the removal of load, a permanent strain of this much is found to be present. The value of modulus of elasticity. Just look at it. When you will see the figure, you will be able to answer this question. We have tried that every topic will be covered with more questions in deflection. So they are saying, let us say there is a strain of 0.0080. So 0.0080, this is the total value, this is given, and they are saying this is corresponding to the 450 value. And they are saying this would be if you are going to load it up to this point only. But when we are going to unload, you know, this angle and this angle are going to be equal. And if this is theta, you know, tangent theta is nothing but Young's modulus. Okay. And they are saying the permanent strain means this much is going to be left in the material. You know, this one, we have said that it is elastic recovery. So you already know this part is the elastic recovery. I am showing elastic recovery with the blue color. This is the elastic recovery. Okay. Permanent remained up to this and it is given as 0.0015. 0.0015 is this value. So guys, you just need to tell the value of what? They are asking you the value of modulus of elasticity. So you know modulus of elasticity from this triangle. This is the triangle in front of you. Very easily. I was telling you about that only, that this type of questions will be coming. So if you see, this value is nothing but 450. Okay. And this value is nothing but 0.0080. So this type of question is simple. This type of question can appear in mechanical, civil, axial. Okay, but power law will not be coming in civil and axi. So you can say this is 0.0015 because they have said this is the permanent strain of this. So I feel everybody can give the answer for this. The Young's modulus will be. Yes, guys. Option, Arvind. Okay. What would be the answer, guys? Please tell me that. What would be the answer, guys? Please tell me that. Arvind have given some answer, which is, I feel he want to say A. Yes. Shravan is saying A. Fanendra is saying A. Rahul Gandhi ji bhi hai A. Very good. Shreyas A. Soumik A. So guys, is it difficult? But if you have not done this type of question before, then you may feel it is difficult. So that is why we have tried ki all the types of the questions would be covered here. So answer for this question will be A. Okay. Wonderful, guys. बहुत ही बढ़िया, शानदार, प्रशांत, आश्रय. Yes, very good. Moving to the next question. Moving to the next question, guys. This is about the principal stresses and strain. You remember that topic also. I have derived the formulas for you. Two planes, AB, BC, which are at right angles to each other. And you can see by looking at that, we can say sigma xx is 60 Newton per mm square. And you can see they have given sigma yy 0. They have given sigma yy 0. Okay. So similarly, you can say that tau xy, it is given as 26 Newton per mm square. So they have given this, and this angle is theta. You know, this is theta. And they have given it in anti-clockwise. So my formulas are valid here. And guys, what they are saying? They are saying find the normal stress and shear stress on the plane. Now, my dear, if you are remembering, this was the direction for the normal stress sigma theta. This was the direction for the stress tau theta. Now, if they give you directions, like they may be giving you opposite to that direction, then you can feel what would be the answer, okay? That tensile or compressive. But here they have not given direction, so I am making this would be sigma theta, this would be tau theta. And everybody remember the formula. Sigma theta was sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy divided by 2 cos 2 theta plus tau xy sin 2 theta. Just apply the formula, you will get sigma theta. Tau theta was sigma xx minus sigma yy by 2 sin 2 theta minus tau xy cos 2 theta. So just put the value, get the answer, guys. Yes, very good, everyone. So what is the answer you are getting, guys? Some of you, I feel, have said the answer as A. Everybody is saying A. TPM, बहुत बढ़िया, wonderful. TPM, बहुत बढ़िया. Vineet, very good. Sophia, very good. Arvind, Sumit, Rahul Gandhi, बहुत ही शानदार, guys. Kunal, बहुत बढ़िया, बहुत ही शानदार. Sumit, very good. So answer is going to be A. when you will apply the formula, sigma theta would be coming out to be 69.2 Newton per mm square. If you see last year in civil engineering, similar question was given. They have given the state of stress and you need to find out sigma theta tau theta. Okay, so the answer is going to be yes. This is A, 69.2 and 6.26. Moving further guys to the next question. This is from Mohr circle. That also I taught you yesterday. Let us see how many of you are going to solve this question. This is Mohr circle. देखते हैं कितने लोग नाम रोशन करते हैं कल जो पढ़ाया था. Let us see. Yes guys. Abhishek, as I already told you, any question can be solved by any of the method, but the point is we would be using that method which will give us the easy answer. Like if someone is asking us find out radius of Mohr circle and we know sigma xx given, sigma yy given, tau xy given, we will apply formula only. Why we will make the circle first and going to calculate? This is not truth and dare going on. I will take the dare and I will take the difficult method. Will take 5-7 minutes of 2 marks question, which is going to be done in 1.5 minutes. Okay, so we would be having that method which will give us answer easily in the less time with less calculations. So here you can see the Mohr circle for the certain state of system. It is given. This thing is given as 250. Look at it. This thing is 250. Okay, and this thing is 150. So you need to find out the principal stresses. You need to find out the principal stresses. So guys, just try to solve. I feel if this is 250, everybody can have that idea that this thing is going to be 125. This thing is going to be 150. I feel very easily you can find out the radius. So when you will be finding out the radius, it would be coming out to be what? Pythagoras. It is 125 ka square plus 150 ka square. And my dear, you know that now Mohr circle I will be using principal stress 1 was, it was sigma star, the center coordinate plus radius. And what was sigma 2? It was sigma star minus radius. And guys, you can see this is the center. So what is the center coordinate? Sigma star is 125. After this, I don't feel if anybody will be not able to do because I have given you detailed explanation of Mohr circle. Especially Vineet requested for that. Okay. And don't worry guys, after today's session, if you find any other topic where you find issue, we would be coming after 20th. Don't worry. We are always there for you. Every topic we would be taking up to the top level. And guys, you know, third Fab, when the mechanical paper is there, you would be having the analysis on this channel. Just after the exam, you have to join here only. We will go for the solution of the entire paper. And if you want to share any question with us, you can also share that as well. Otherwise, we would be getting from the students. Okay. And fourth, civil analysis will be there. And after that, next weekend, we would be having XC analysis. So be ready. Every analysis will be there on this channel for civil and mechanical peoples. So when you will be solving this, first of all, you would be finding out the radius. Can you tell me what you are getting as the radius value? Majority of you have answered it. What you have got the radius of Mohr circle? Kya are radius of Mohr circle? Can you tell me the value guys? Anybody? Yes, answer if you are asking me is correct. B is the right answer. When you will be finding out sigma 1, it will be coming out to be 320.26 and this will be coming out to be minus 70.26. Yes, very good. So 195.26 will be the radius. Okay, very good. Fine. So I feel everybody can do now. It is a very good question for Mohr circle point of view. Wonderful guys. Bahut hi badhiya, shandar. Moving further guys, moving further. Now we are moving to the next part, which is related to the support reactions calculation. This is SFD BMD. Sir, I have taken it in a very nice manner. So let us see how many of you are able to solve this. I will give you hint, don't worry. How to solve it. A beam ABCD with simple support at ABCD and internal hinge is there. This is the internal hinge. Okay, so this is the compound beam because two beams are connected with this point. And guys, yes. Ha, Shreyas, very good. Okay, sigma star is 125. I feel you want to say it is sigma 2. Fine, sigma star is 125, na? Okay, so when we are talking about this, we will be dividing this beam into two parts. I am giving you the hint if you find any difficulty. This is the case. Okay, this is the internal hinge. And you know, when we have this part, here we would be having a support reaction RD. Here it is a 20 kilonewton for the equilibrium of the body. Obviously here a reaction would be produced by the support internal hinge. So here we would be having the RC. Okay. So from the symmetry you can find out, because this is 1 meter, this is 1 meter. And once you will get here at C, there is no force. So if we are assuming here upward direction, here it would be a downward reaction. So this is RC here. And here you are also having one force of 20 kilonewton here. And once again you can see the distance here is 2 meter, 2 meter and 1 meter. 1 meter. So guys, just you need to do one thing. First of all, find out RC and RD from here. I feel everybody can say by symmetry 10 kilonewton will be there. And then you need to take summation moment. This is A and B. Take summation moment at B to be 0. You would be able to find out, you need to find out the reaction at RB. Okay, take the net about A. Take summation moment about A. So when you will be taking about this, you can say here will be a support reaction RB. Everything is known to us other than RB. You can find out the RB very easily. I feel some of you have already answered. Yes, Madhuvamshi, I am happy to see you. Yes, I remember you very well. Yes. So I feel your preparations are going well and this time you will crack it. Wonderful. Sham Sundar, Jai Gandhi, TPM, everybody have given the answer as correct only. So when you will be going for summation moment about A, you would be having RC into 5. This is in clockwise. Then minus RB into 4. Then plus 20 into 2 equals to 0 will give you RB value. So yes, answer is done. Question is done. Very good. Moving to the next question. Okay. So guys, now I will call Abhinav sir. Okay. Some questions sir will be doing. Then once again I will come back because I have much more questions also. Sir, आ जाइए फिर मैं आता हूँ. ओके हाँ सुशील, अभी काफी कुछ होना है. अभी तो एक 2 क्वेश्चन कराया मैंने आपको, और भी करेंगे. ठीक है, इसमें कोई डाउट हो तो पूछना. ओके ओके, यू आर परस्यूइंग एमटेक, दैट्स ग्रेट मधुवंशी. चलो सर मैं थोड़ा इधर हो जाता हूँ.
कहीं भी हो जाए सर, मैं तो कभी भी गिर सकता हूँ.
ओके so guys, this is the question.
Okay, so guys, most of the questions that I will be taking, I will also be doing it for the first time. So let us see the master does first or the students. Okay guys, keep sharing the session to all the students. A composite bar made up of steel, this is made up of steel, modulus of elasticity is equal to E, is hanging freely under its own weight. Okay, this is under its own weight, it is hanging freely. Okay. Self weight and cross sectional area of RQ are, this RQ are 2W and 2A. Okay. So this will be guys 2W, the weight is 2W and the area is 2A. Okay. Now while those of PQ bar, this PQ bar is W and A. This W and A. Okay sir, got it sir. Okay sir, got it sir. Considering self weight of the bar, the displacement of point P, how much this small point P will move? How much this small point P will move? Okay. Now guys, whatever this total bar will be displacing, okay, deflection of point P is how much this RQ will be going downward due to its weight and whatever the forces. How much this will go, suppose 3 mm. So this P will go 3 mm. Okay, so how much is the delta RQ? That much P will go down. How this is suppose going 7 mm. So P will go down by 7 mm. And this is going by suppose whatever mm. Let it be 3 mm. So again the P will be going by that much amount. So delta RQ plus delta PQ. Let me tell you guys. Suppose from childhood, my legs are increased by 7 mm. My upper body is increased by 3 mm. So this point is moved by 10 mm. Na? Suppose my legs are moved by 7 mm. Upper body is moved by 3 mm. So this is moved by 10 mm. Na? Okay. Thank you. Thank you, Suhil Bhatt. Thank you. Okay. So now delta RQ plus delta PQ. Now what is delta PQ? What is delta PQ? Okay. So delta PQ due to its own weight. Okay, how much this will be deflection? Due to own weight, it's WL by 2A, na? It is WL by 2A due to its own weight. Okay, so this is WL by 2AE. Okay, now I want to find out the value of delta RQ. Correct? So delta RQ, now delta RQ will be displacing by two things. One, due to its own weight, and this weight is acting external for this. Now I can write down this as, see, delta RQ, see, this is R and Q. So due to its own weight, plus 1 due to the downward this PQ bar, it is applying a force W on this. Two things will be there. Okay, so delta RQ due to this W, it is W. What is the length? Length is L. What is the area? 2A into E. This is due to this W. Okay, this is due to this W, external weight. Okay, this W is this. Okay, so this is WL by 2A plus due to its own weight. Okay, this yellow one is due to this bar, the deflection, because this is acting as external on this, na? Okay, now, so guys, suppose I am standing like this. My legs will be in compression. My legs will be in compression, correct? So one compression is due to this load. This load is external from my kamar. एक सर कमर को इंग्लिश में क्या कहते हैं? From my this belt portion, from my belt portion above body. So whatever this weight is external for my legs. Due to this weight, it is going downward. Okay, and due to own weight of my legs, it is again compression, na? Okay, okay, yes, waist. Someone is asking. So due to this W, it is WL by 2A, and due to its own weight, deflection is W, whatever the weight, W is here 2W, into L by 2 into A. What is A? 2A. I hope you understood what formula I applied. WL by 2A, na, due to its own weight. So what is W? 2W. L by A. WL by 2A. So this is 2. A is 2A into E. So what is this? What is delta RQ? WL by A common 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2, है ना? So 1 by 2 plus 1 by 2 is WL by A. 1 by 2 plus 1 by 2 is WL by A. So WL by 2A and WL by A. So 1 by 2 plus 1 is 3 by 2. That is B option. Everybody on the comment box, genuinely give me yes or no. Have you understood or not? Have you understood or not? If you understood, either give me yes, Y, or put a heart sign. धीरे से आप भी लगाओ. Tell me. Got it? Okay, writing किसका अच्छा है, मेरा या धीरज सर का? First time ever in my life I am comparing my handwriting with another in a positive manner. Otherwise I have always compared किसका गंदा है, your or mine. First time ever in 34 years. Smart तो मैं हूं ज्यादा, मेरे को पता है. Smart I am. Okay. Next question, guys. Excellent question. Excellent. A prismatic bar of cross-sectional area 1 mm square. The cross-sectional area 1 mm square. Young's modulus is 200 gigapascal. That is 10 to the power 9. Okay, is fastened between two rigid walls. The support reaction at B and A are. Okay, guys, I can make any direction. Okay, if my answer is coming in negative, that means my directions are wrong. Okay, if my answer is coming in negative, that means my directions are wrong, guys. So this is RB, this is RA. Chalo. Okay, yes, कुणाल, आज मेरा है. तभी मैं अच्छा लिख रहा था. अब देखो गंदा लिखता हूँ. वो पहले वाले में बस जीतना था मेरे को. ओके, चलो, क्या निकालना है आपको? आरबी और आर ए. आप कोई भी डायरेक्शन मान लो, गाइस. नो, देखो, गंदा और बहुत गंदा में जो गंदा होता है वो अच्छा होता है. गंदा और बहुत गंदा में जो गंदा होता है वो अच्छा होता है. Okay. So guys, some equilibrium condition, left hand side force is RB plus RA. Okay. And right hand side force is 13.6 plus 27.2. Okay, this is one equation. One equation will be delta AC plus delta CD plus delta DB is equal to 0 because it is fixed. Okay. So cut a section here for AC. See from left or right, your choice. Let us see from left. RA going away, so positive. RA into L, that is 100 upon AE. AE तो सबका cancel ही जाएगा because it is constant. For delta CD, cut a section here. Okay, see from left or right. Let me see from left. Let it be only because if I'm seeing from right now, one more unknown will be introduced. Okay. So from left hand side, RA into L, that is 200. Okay, not RA. Okay. So RA going away positive. 13.6 is coming inside. 13.6 minus. You can convert in proper units also. I'm not showing that. I'm only telling you the concept. Okay, plus. Cut a section here. See from left hand side. So RA going away positive and others are coming inside. 13.6 minus 20.7.2, length is 300 upon A. Okay, is equal to 0. So one equation, one unknown from here, guys. The value of RA is 24.93. Value of RA is 24.93 kilonewton and value of RB is 15.86. Value of RB is 15.86 kilonewton. So 15.86 and 24.93. That is option number B. Okay. Now guys, one thing I want to tell you here, everyone. सर मुझे हमेशा क्लास का टाइम लगता है, सब आता है, लेकिन एग्जाम टाइम में पता नहीं क्या होता है, क्वेश्चन रॉन्ग हो जाता है. तो एक बार आप यार वो दो फुल लेंथ मॉक टेस्ट, और फुल लेंथ मॉक टेस्ट दे अपने गेट वाले टाइम पे ही. ओके, और उसको जितना हो सके देखो, एग्जैक्टली आप उसको गेट नहीं समझ पाओगे. जब बाहर जाओगे, बस में जाओगे, एक दिन पहले थोड़ा सा टेंशन में रहोगे तो वो अलग दिन होगा. उससे पहले हम गेट एग्जैक्टली कभी भी नहीं समझ पाएंगे. फुल लेंथ टेस्ट देते हुए गेट जैसा ही समझ पाएंगे, क्योंकि आपकी वही टेबल होगी. ठीक है, चप्पल में आप एग्जाम दे रहे होंगे, वहां हो सकता है जूते में दे रहे हो, तो 100% कभी भी कोई नहीं बना पाएगा, यही हकीकत है. लेकिन जितना हो सके ट्राई मेक इट लाइक अ गेट एम्बियंस एंड गिव द एग्जाम. ओके, चलो. नाउ दिस इज द क्वेश्चन. ओके, और in this question what you have to find out the magnitude of shear force immediate to the left of B and immediate to the right of B. What will be force? Okay, immediate to the left of B and immediate to the right of B. Come on, Dhira sir, catch. कुछ नहीं, ऐसे चेक कर रहा था आपको आता है कि नहीं आता, भी जवानी बची है कि नहीं बची आप में.
अगले मैच में देखना फिर. 50 नहीं मारी तो मैंने.
Okay, now guys, okay, first of all, see here, it is hinged at B. So here it is hinge. Let it be here RA. Let it be here RA. Since it is hinged now, so what is bending moment at B point? Bending moment at B point is 0 because it is hinge. So see from left hand side, so it is RA into a 3 span continuous beam of 12 meter internal hinge. The section B is a midpoint of AC. Okay, so it is midpoint of AC and AC is 4. So that will be 2. So RA into 2 is equal to 0. That means RA is equal to 0. Okay, now just left of B. That means here, XX. Okay, so I am cutting. What is shear force? I told you yesterday, na? What is shear force? I told you yesterday, na? AXX. So here this RA is 0. So what is the internal force coming here? If RA is 0, then for force equilibrium, what is the force coming here? For summation Fx is equal to 0. So this should be 0, na? So at XX section, that is just left of B, it is coming 0. So of course C is the answer. But let me check right hand side also. Okay, now suppose I cut right hand side, this YY section. Okay, this YY section I am cutting now. Now, when this YY section I am cutting now, everyone please see this. Okay, here it is XX. Okay, I want now shear force on the right hand side, that is YY. Okay, this is YY. This is YY. Okay. Now at XX, what is the shear force here? What is the shear force here? 0. Okay. At here, it is 20. So only force equilibrium. I'm not going for the movement equilibrium. So at YY section, if this is 0, this is 20. So how much internal force is coming? 20. So it will be 20. Guys, have you understood the concept? Sumit, have you got it now? It is given. Hinge at B. Internal hinge, we have not mentioned. We have not taken. It is mentioned. बताओ धीरज सर मेरे लिए पानी लाए मतलब M.Tech, the god of SOM, giving water to father of SOM. Just kidding. समझ गए क्या? Okay. Now, fourth question. Everyone. जल्दी बताओ यार, सब मैं आंसर रट के लाया हूं यार. कॉन्सेप्ट थोड़ी नहीं आता मेरे को कॉन्सेप्ट थोड़ी नहीं आता. मैं रट के लाया हूं, भूल जाऊंगा फिर. जल्दी करो. Okay. So guys, first of all, this is a sagging moment. So top portion is compression and the bottom is tension. Okay. And the cross section is like this. The cross section is like this. Okay. So when the cross section is like this, let me make it little bigger. So bigger बनाऊं? इंक खत्म तो नहीं हो जाएगा सर? कुछ रिप्लाई नहीं, मतलब नो रिस्पेक्ट. Okay, compression at the top and tension at the bottom. Okay. Now the CG of this portion is, if the diameter is D, then the CG is, from here it is 2D by 3 pi. This is the neutral axis. Neutral axis is the centroidal axis I told you yesterday. Okay. So this distance is 2D by 3 pi. This is 2D by 3 pi. So of course this total is D by 2. So this is D by 2 minus 2D by 3 pi. Correct? Correct guys? So this is, मतलब ये जिसको ये आता होगा ना, मतलब everyone knows the concept here. The only thing is you know the CG of this or not. Okay. So sigma T by sigma C from similar triangle. Sigma T by sigma C from similar triangle is 2D by 3 pi divided by D by 2 minus 2D by 3 pi. So this is the key concept here. Okay, and from here guys, the answer will be 0.74. This is an NAT type problem. 0.74. Got it? Guys, let me tell you in NAT type questions na, what is happening. I am telling you some key, क्या कहते हैं उसको, छोटी छोटी मगर मोटी मोटी. See, NAT type question, suppose answer is 5. Suppose answer is 6.2. Suppose answer is 7.62. So they will give only this as answer. If you have given 5.1, it will be treated as wrong. If you have given 4.9, it will be treated as wrong. Only this is given. But sometimes complex calculation is there. So they give answer that 5.2 to 5.6, all answer will be taken as correct. For the complex calculations. And when this is a simple calculation, they give only one answer. Otherwise, they give a range. Second concept, guys. I am telling you very important, guys. This one very important. Guys, sometimes MSQ comes, na? Guys, you know why in MSQ and NAT there is no negative marking? You know the reason for that? You know the reason for that? Because guys, in MSQ and NAT, how many options are possible to write? Infinite. Okay. Okay, how many? Okay, sir, जब तक आप दोनों नहीं सो जाएंगे, हम भी लगा रहेंगे cancel exam now. Okay. Okay. NAT, there is infinite options available. So infinite options available na. Now, a random answer will be correct. You randomly guess it is correct. It is almost impossible. So therefore, no negative marking. Similarly, MSQ guys, there are number of options available. If 1 is correct, 4C 1 options. If 2 are correct, 4C 2 options. If 3 are correct, 4C 3 options. If 4 are correct, 4C 4 options. So there are numerous options. Out of that, randomly choose one and that is correct is very, very rare event. So that is why a random guess will be correct is very rare event. So no negative marking. But in MCQ, a random guess also has a 25% probability that it is correct. Because there are only 4 options in MCQ. So that is why there is no negative marking. Now listen what I want to say. Sometimes in MSQ what happens, that a question is written and option A is shear force at this location is this much, option B shear force at this location is this much, option C bending moment at this location is this much, option D bending moment at this location is this much. Usually what will happen, either answer will be AC, either the answer will be AD, either the answer will be BC, either the answer will be BD. Give me yes or no. I see only C can be answer. Okay, might be both shear force are not matching. Only C can be answer. Even MSQ can have one option also correct. But that is that much twist they will not be generally asking. So either AC, either AD, either BC, BD. Now again in MSQ, actually it is MCQ na. Actually, MSQ becomes MCQ na. 4 options correct. And 25% probability that it is correct. And there is no negative marking also. And if you find 2 or 3 such MSQs, please go for them. Please go for them. Have you understood the logic? The logic of probability? Okay. Now, bending stress. If in a rectangle beam, the depth is doubled, the maximum bending stress will be reduced by a factor. If depth is doubled, okay. So, here is this much, here is the sigma max. Now, when depth is doubled, okay, it is 2D, it is D. So, when the maximum bending stress will reduce by a factor. So, when depth is doubled, so here, what is this? So sigma max is m by I into y. So di is having d cube and y is d by 2. Okay. So here also sigma max is equal to m by I into y. M has nothing to do. I is b into d cube. That is 2d cube. And again here it is 2d by 2. Depth is here 2d by 2. Okay. So here it is d 1 by d square. In fact 1 by 2 और 2 को भी काट दो वैसे तो चलो 1 by 2d square. And here it is 2 to 2 cancelled. 1 by 2 से 2 कटा 8d square. Okay. So 1 by 2d square to 1 by 8d square. So it is reduced by how much times? 4 times. Understood the option? Understood or not? Tell me. Tell me guys. Come on. सर चेक कर रही सुल्तान भाई को चेक करोगे
क्वेश्चन नंबर देख रहा हूँ
सुल्तान भाई को चेक करोगे
चेक क्या करना गलती है
Okay. Now guys, this is the question. Everyone, the frame shown in the figure below carries a vertical load P. कहाँ गया P? 10 kilonewton at its end D. Okay, D पे लग रहा है. The frame is fixed at A. यहाँ पे fixed है. यहाँ पे fixed है. Okay, has a roller support at B. Roller support at B. Magnitude of reaction force at B. Okay, of course, roller support cannot provide this reaction. It can only provide this reaction. Okay, it can only provide this reaction. Okay, now you have to do this. You have to do this question. Everyone, come on. Come on. अब एक्चुअल में ना जो क्वेश्चन था ना सर ये ऐसा था ये ऐसा पर इससे भी सेम ही आएगा actually this question was like this. Okay, but it's okay. He has made 180-degree shift, but again the answer will be same. Okay, because why answer will be same? Because for a particular structure, if I'm seeing like this or if I'm seeing like this, the reaction will be same there. Reaction will be same there. Now, if this I am transferring, sir, ये question मैं कर पाऊंगा क्या? If this load I am transferring here, so it is 10 kilonewton, and this 10 into 20 movement, 20 kilonewton meter movement, 10 I am transferring here. Okay, RB is here. Now, if you change it 90-degree clockwise or anti-clockwise, okay, either you don't have to change. If you change it like this, twisting it 90-degree, okay, twisting it 90-degree. So this is RB, and if I twist it like this, ऐसा, so this will be 10, okay, and this will be 20 kilonewton meter. Okay, neglect the axial force, इसका कुछ नहीं करना है. Now, actually the deflection of B point is 0. Okay, actually you can see here also, yaar. It is not needed that you will be seeing here. You can see here also. This 20 will be making some displacement at this point, and RB is also making some displacement, and net displacement has to be 0 because it is support. This 20 movement will be applying some displacement here. Okay, and RB is also applying some displacement, and net displacement has to be 0. Tell me the answer. Jaldi, jaldi, jaldi. Everybody, चलो बताओ. चलो फटाफट से बता दो भाई. Net displacement at the B point has to be 0. So the displacement due to this movement and due to this RB. Everybody please tell me. चलो 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 चलो. कहाँ गया? इस मूवमेंट को यहां ट्रांसफर करो, इस मूवमेंट को यहां ट्रांसफर करो. एक्सियल फोर्स नेग्लेक्ट करने के लिए कहा है, तो m इज इक्वल टू फर्स्ट ऑफ ऑल 20. ओके, ये मूवमेंट की वजह से यहां डिफ्लेक्शन कितना होगा? या दिस द डिफ्लेक्शन ऑफ दिस ड्यू टू दिस. ओके, ट्रांसफर इट हियर. ओके, ट्रांसफर इट हियर. सो मूवमेंट विल बी ml स्क्वायर बाय 2 ei. ओके, एंड rb विल बी rb into lq by 3 ei, and both has to be same. Okay guys, this you are thinking like this na, this you are thinking like this na. So now I guess this is a clockwise movement na, so it can be, you can think like this also. So this will be putting it downward. If you transfer this here, ml square by 2i, and due to rb it is rb lq by 3i. ei to ei will be cancelled. L value is 3 meter. L value is 3 meter. No, L value is this 3 meter. Okay, both are 3. And from here, the value of RB is coming as 10 kilonewton. Give me yes or no. Have you understood, or should I explain again? Give me yes or no. 6.67 कहाँ आया? 6.67 नहीं आया यार, 10 आया. करके दिखाऊं क्या? M20 है और इधर से EI कटेगा तो 2. EI उधर भी कटा. So RB into L is 3. L square to LQ will be cancelled. Only L will be written. That is 3 by 3. So RB is 10. Yes, Sumant, good. अगर वो ब्रैकेट वाला सेंटेंस नहीं दिया तो नहीं, क्योंकि ब्रैकेट विल बी ओनली कंप्रेसिंग इट हियर. वी आर फाइंडिंग नेट डिफ्लेक्शन इन दिस डायरेक्शन इज 0. दिस 10 विल बी कंप्रेसिंग इट दिस साइड. Okay, but this movement and RB is displacing in this direction. Okay, let me show here. This RB is displacing in vertical direction. This M also displaced on ml square by 2 in vertical direction. But this force is only compressing in this axial force. Again, no effect. Have you got it now? Give me yes or no. Give me yes or no. Everybody? ये भी आप ही करा
नहीं सर मेरे पास है वो ओके गाइस अब कुछ क्वेश्चन मैं करा देता हूँ सर थक गए थोड़ा सा चलिए गाइस सो वी हैव सीन दिस क्वेश्चन ये भी हो गया था वी हैव सीन this also now let us see this one so guys this question is saying along the length of a beam the extensional as well as compressive strains have been recorded at the top level 150 mm below it across the depth as this and this. So I am telling you what they are saying. They are saying that they have measured the strain diagram for a particular member and they are saying that strain is this and this. So this is 4 into 10 to the power minus 6 at some level and then 150 mm below. They are saying this strain is like this. This is nothing but 1 into 10 to the power minus 6. The total depth of the beam is 240 mm. So this total depth is 240 mm. Total depth is 240 mm. You know this is from the bending. Yes. So let us see. They are saying if A1, A2 are the areas of the cross section under tension and compression, then the ratio of A1 to A2 is, okay, that is asked. You know that whenever we are talking about bending is a kind of normal stress, hai na? And you also know that we write sigma by E is equal to epsilon generally. That is what we write. So sigma can be written as E into epsilon and sigma is P by A, okay, or you write in the form of mz, whatever, m by z. So whenever we are saying this, you can see the relation between area and strain. So it is looking like strain is inversely proportional to area. So if they are asking the ratio of A1 to A2, if they are asking the ratio of A1 to A2, it means you need to find out the ratio of epsilon 2 to epsilon 1. Here I feel this is epsilon 1, this is epsilon 2. Now by using the similar triangle, you can find out epsilon 2 because epsilon 1 is given to us. First of all, what we will do? What we will do? This strain is known to us, this strain is known to us. Okay. So in that case, if you are going to take this similar triangle, you are taking this similar triangle, this is red triangle and we are having, let us say, a blue triangle. This is the blue triangle. Okay. And let us say this distance is x. So you can write it as 150 plus x. 150 plus x divided by 4 into 10 to the power minus 6 can be written as x divided by 1 into 10 to the power minus 6. From here you can find out the value of x. Once you know the value of x, you would be knowing this. You would be knowing this depth. Okay. And now, my dear, you know if this depth is known to you, you can also use these two similar triangles, this triangle and this triangle. From here you can find out epsilon 2. First of all, find out the value of x. Yes. Saman, that is fine, but if you are going to take it in that way also, like m upon I, so you know what is I. I is a y square or a x square. So in that way also you will be having the similar thing. There is no problem in that. Okay. So what you are getting, Fanindra is saying 50. So I am telling you what you would be getting this distance. Yes, it would be 40 and x would be coming out to be 50. Yes, x is coming out to be 50. So this total is 200 and this is 40. So you can say, my dear, or you can see in this way that sigma is directly proportional to y ki power 1 or strain is directly proportional to y ki power 1. So we can also write here y2 by y1. Okay. So in that way also we can do, but I would be writing in the form of strain. We will find out the strain, that will be easier for us. If we want to find out this epsilon 2, we can write that epsilon 1 by epsilon 2. If you find out this will be the ratio of this by this. Okay, so you would be having this as 200 by 40. So from here you can put this value here and you can find out the ratio. Tell me what is the answer you are getting. Yes. Yes, yes, yes. Suhil, is it your doubt? Please tell me. So the answer is coming out to be 5. Are we getting the value as D? Are we getting the value as D? Please tell me that. Badri, very good. Somik, sir, extension stress is compressive. Dear, it is not like that ki you can take it doesn't matter whether you are taking it compressive or tensile, but they have mentioned it as along the length of a beam, the extensional as well as compressive strengths have been recorded at the top level 150 mm below it across the depth as this and this. So they have extensional means whenever you are going to extend only, but as they have mentioned that both things, because in bending you have tension also, compression also. Okay, and I am telling you that here whatever this diagram I have made, actually this diagram was given, but by mistake this diagram was not made by that typist. Okay, so that is why you are thinking ki one is tensile, other is compressive. Actually this diagram was mentioned, this was 1 and this was 2, this 150 mm was given. So if the figure would be given, you would not be confused like that. Okay, so answer is coming out to be D. Is it clear? Yes, Suhil, you understood now? Shomik, you understood now? Very good, Kunal, bahut badhiya. Moving further, so D would be the right answer, guys. Okay, very good, Vinay, bahut badhiya. Moving to the next question, guys. This question is, okay, let us see now some other question from different topic. Yes, this is from the torsion. So I told you yesterday, torsion also a circular solid shaft of span 6 meter is fixed at one end and free at the other end. So you are having a shaft like this, which is 6 meter long. Okay, and my dear, if this is 6 meter long, they are also saying it is fixed at one end, free at other end. Twisting moment of 85 kilonewton meter is applied. Okay, so next we are going to have the torsional rigidity of this. So we are having GJ, you need to find out torsional strain energy. Strain energy formula is T square L by 2 GJ. I feel everybody would be knowing. Okay, T square L by 2 GJ. So you need to find out this strain energy. Just try to find out. If you don't remember this formula, you can go like that. U is equals to half into T into theta. Okay. So it will be half into T into TL by GJ. Okay. After this question, we will see some question from deflection now. After this question, we will see some question from deflection now. And yes, tell me what would be the answer, guys. So guys, don't worry if you find any separate topic. We will be coming up after marathon also. Actually, we are also planning, sir, कैसा रहेगा अगर एग्जाम से पहले एक सिविल वर्सेस मैकेनिकल वॉर हो जाए?
अभी कर लेते हैं सर.
अभी कर. Yes. So guys, after marathon, if possible, we will come up with one more civil versus mechanical war. Okay, from 21st. Yes, so from 21st to 22nd. Yes. It is coming. Okay, so 0.54 Rohan is saying. What about others? बाकी लोग क्या कह रहे हैं भाई? 0.54 आ रहा है, कुछ और आ रहा है? Rohan have given the answer as 0.54. What about others? So guys, do like and share the session. Deflection questions now are going to be started. Very good, Shomik. Very good, Dr. Strange. Yes, Badri Vishal. Very good, Sophia. The answer would be B for this. 0.54 kilonewton meter is the right answer. Shreyas, very good. So guys, moving to the question now from the deflection, I am telling you. First of all, let us see from where deflection questions are starting. Okay, from here they are starting. So guys, this is the very first question from principle of superposition. Okay, as many students said, sir, if possible, do some questions on superposition. This is one of them. A cantilever beam of flexural rigidity 81 meganewton meter square is loaded as shown in the figure. And you can see 900 kilonewton meter is the bending moment applied and 100 kilonewton is the shear force applied. Okay. So my dear, if that is the case, and what is the question actually? They are saying the bending moment at fixed end is. This is, I feel, not from deflection, but this is a very easy question. You need to find out the bending moment. You need to find out the bending moment at 9 meter. So from here, 9 meter will be this. You need to find out the bending moment at this support. Tell me what would be the answer. Let us see how many of you are able to give the answer for this. 900 kilonewton meter is the moment, 100 kilonewton is the force acting. I'm making this figure separately here so that you can see the options. They have given this as 100 kilonewton, and moment as 900 kilonewton meter. So starting with this, the next portion will be of deflection type. So if you would be finding out this bending moment, you know that bending moment at a section XX, how we can write it? This is XX. You can see to the right hand side, this is sagging. So plus 900 minus 100 into X. They are asking at X is equals to 9 meter. The answer will be coming out to be 0. So 0 is the right answer. That is correct. But what is the second option? Second question that is interesting. The deflection at the free end. So my dear, once again I am making the figure. They are asking the deflection at the free end, where this is the 100 kilonewton and this is the 900 kilonewton meter. So my dear, I feel everybody know the principle of superposition. We are going to have a force P and a moment M, and I feel everybody know what principle of superposition says. It says the deflection at a point because of multiple loads can be found out as deflection at A due to the force plus deflection at A due to the moment. Just try to find out. You know the formula because of forces. Force is downward, so minus PL cube upon 3EI. I have shown you the table, plus ML square upon 2EI. So guys, just put the value, get the answer. This would give you the deflection at A. Yes, what would be the deflection at A, guys? What would be the deflection at A? What would be the deflection at A? Tell me, guys. What would be the deflection at A? You need to find out deflection at A. All the things are given to you. Wonderful, guys. Yes, we are having next two questions also from deflection. So be ready. Solve it. Yes. Okay. थोड़ा सा calculation है guys, but this type of questions are coming in GATE. You need to find out deflection at A. Okay, minus P. What is P? 100 kilonewton. Minus P 100. Okay, if you are missing the data of EI, I am showing you that. EI is 81 meganewton meter square. They have given you. EI is 81 meganewton. 81 meganewton meter square. So it is minus 10 into length upon 81 meganewton. Mega means 10 to the power 6. Okay. So you are going to say this is, first of all, PL cube upon 3EI, and then we are having plus bending moment is 900 kilonewton it is. Okay, this is also kilonewton into Alka square upon 2EI, 81 into 10 to the power 6. You need to solve it. I feel 150 mm is the right answer. Shomik have given the right answer. Rishabh have given the right answer. Fanendra have given the right answer. Wonderful, guys. Rohan, you have done some calculation mistake. C would be the right answer. You would be getting 150 mm. Okay, this 150 mm is coming downward or upward? Tell me that. This 150 mm is coming downward or upward? This 150 mm is coming downward or upward? Downward or upward? Downward or upward? Yes, very good, Sophia. Very good, Mayank. Shreyas. Wonderful, guys. So 150 mm upward or downward? Which one is bigger out of them? अरे नेगेटिव आ रहा है, पॉजिटिव आ रहा है? Yes. Okay, fine. You are getting it positive 150 mm. There is no problem. Very good. The answer. Moving to the next question, guys. This is once again the question from deflection as per your request. The vertical, this is once again from principle of superposition. The vertical deflection at the free end of a cantilever beam subjected to a load of 100 newtons shown in the figure. So guys, what to do for this type of question? I am giving you the option for that. So my dear, this is the beam. 100 Newton is acting here. This distance is 2 meter and this distance is 1 meter. And my dear, because of load the deflection will be going like this. Up to this, it will be going like that. And from A to B, there is no load. Bending moment is not there. So here it will be a straight line. That also, sir, I have told you when sir was telling you the bending equation yesterday. I remember that. So guys, you need to find out this deflection. Na? They're finding free end. Deflection at free end. Okay. Fine. If you are having any doubt in the upward, downward, just I am telling you, if you are getting the answer as positive, it is upward. If you are getting as negative, it is downward. Okay, you can see this term is negative, this term is positive. Okay, so you check the value. If you find answer is not given in plus minus, they have just asked the magnitude. So I also don't know whether it is plus or minus, but you can check it. Okay, fine. Moving to this question, guys. So you know, when you want to write down the deflection at A, we can write this is deflection at B. And guys, if this angle is theta, we can write this part as this is theta at B into AB. Because you know, if we are having this, if this is R, this is theta, we write this as R theta. And as theta is very small, so we can approximate it as a straight line. So deflection at A is deflection at B plus theta at B into AB. And my dear, when you will write deflection at B, it will be coming out to be minus, load is 100 Newton, minus P, assume it as P, minus P, then L ka cube upon 3 EI. You need not to put the value of EI. What is theta B? Theta B is, you know, here the angle slope is going to be clockwise, is considered as negative. So you can say this is going to be minus P L ka square upon 2 EI. Just put the values in this, get the answer. Let us see how many of you give the right answer. Okay, Rohan, please check it again. Rishabh is saying 1400 by 3. Very good. Wonderful, guys. Okay, Sumant, but I am not preparing you for this question. Huh? I am preparing you for this type of question. You forgot? Yesterday I told you that reflection question I will be telling you with concept. So I wanted to tell you this concept, not that question actually. Okay? So that's why I am talking in general way. Not by looking at the answers. Okay? Fine. Kunal is saying B.
क्यों नहीं हो सकता? क्यों नहीं हो सकता? How it cannot be a round number? If instead of 1400 it will be 1500, then 1500 by 3 will be 500 EI.
नहीं क्या कहना क्या चाह रहा है ये?
वो कह रहा है कि राउंड वो बाकी तीन ऑप्शन में.
Sir, this question no need of solving deflection, cannot be round number.
No, Samant, if that is instead of 1400 it will be 1500. That 1500 by 3 will be 500 EI. You want to say something else?
I didn't understand, sir.
सर देखो पीछे ऑप्शन देखो ना, A, C और D में डिनोमिनेटर नहीं है, तो ही सेइंग इट कैन नॉट बी अ राउंड नंबर.
नहीं, बट ऐसा क्यों?
ऐसे ही वो कह रहा है.
Okay. Sumant may be typing something for that. I thought कि वो ये कह रहा है कि इसको सोल्व करने की जरूरत नहीं है, वैसे ही हो जाएगा.
कैसे?
मतलब नॉर्मली देख के.
सर
मतलब जैसे मैं ये कॉन्सेप्ट बता रहा हूँ ना कि दिस इज थीटा, सो आई थॉट कि यू डोंट वांट मी टू राइट दैट दिस ऑल द एक्सप्लेनेशन आई वाज राइटिंग ना. सो आई थॉट कि सर व्हाई यू आर राइटिंग एक्सप्लेनेशन. Okay, so what would be the answer? A or B? A or B? A or B? B would be the right answer. 1400 upon 3 EI. So answer for this will be coming out to be 1400 upon 3 EI. So B would be the right answer. Okay, fine. So Rohan, Shreyas have given the right answer. Gaurav have given the right answer. Dr. Strange have given the right answer. Kunal have given the right answer. That's really wonderful, guys. I'm so happy to see your wonderful response. Sir, this question you have also added. Would you like to do this? Okay, guys. So this question also I am doing. So guys, in this question, ओके एक्चुअली सर वो डिनोमिनेटर की बात कर रहा है. अरे यार देखो, मैंने आपको तरीका बता दिया है, ठीक है, बट व्हाट इज दिस डिनोमिनेटर?
इट्स डेफिनेटली इंटीजर इन डिनोमिनेटर. Why?
What is the reason behind that?
If instead of 1400, it is 1500. Only this question. अच्छा. इस क्वेश्चन में वैल्यूज कुछ ऐसी
अच्छा वैल्यूज ये 2 और 1 3 दी हुई है. Because of that they are saying
PL cube by 3i. PL cube 8 by 3. अच्छा. इस क्वेश्चन के लिए.
हाँ इस क्वेश्चन के लिए by sir actually he would like to say because this is 3 EI, this is 2 EI. So because of that, if we take LCM 6 EI in that way, I feel न्यूमरेटर भी तो चेंज हो सकता है.
न्यूमरेटर भी तो.
Okay, no issues guys. अगर आपको ऐसा कुछ समझ में आ रहा है तो. Okay, so next question guys. This is the question. A cantilever bracket as shown in the figure below is subjected to a concentrated load P at and D, the deflection at B. Here, my dear, they are asking you deflection at B. If they would be asking you deflection at D, we could use the strain energy method. Because the strain energy method is giving you the deflection at the point where load is actually acting. Okay, that directly we are finding out. Otherwise, we need to go for the pseudo load method. But here they are asking you at B, and this question can be done using the equilibrium. This type of question I have done many times in the classes. This is the case BA. This is the case BC. And this is CD. And my dear, you know at D some load P is acting. And for equilibrium of CD, BC will be supporting CD. How it would be supporting? By applying a force here and by applying a couple here. This force is P and this couple is P into L by 4. Okay. So this is P and these two things are coming from where? They are coming from BC. BC is supporting it. And if it is coming, CD will also react to BD. And here it is upward. Here as a reaction will be coming downward. Here it is clockwise. Here it will be anti-clockwise. So for equilibrium of BC, AB will help. For this, AB will be applying one force here and couple here. P into L by 4. So BC will give reaction to AB. So here it is upward, here it will be downward. Here this is here it will be here. This is P, this is PL by 4. So now it becomes principle of superposition in front of you. Now it is principle of superposition. This is P and this is PL by 4. So my dear, you know once again deflection at B will be coming out to be deflection at B due to P plus deflection at B due to PL by 4. So it is minus PL cube upon 3 EI plus ML square upon 2 EI. Put the value, get the answer guys. And don't worry, we are also having... Okay sir, how many questions in SOM will be completed? Okay, this is the last question. मेरे पास तो बहुत सारे क्वेश्चन है पर मुझे लग रहा है आप थक गए हैं और कल फिर आपको आना है मैराथन के लिए, तो मैं यही रोक रहा हूँ. मेरे पास तो अभी 20 और क्वेश्चन है, ठीक है. तो मैं पूरी रात का प्लान करके आया था. But don't worry, tomorrow we have marathon once again, so I will be leaving here. And don't worry guys, right now we are doing 10-20 question every day, but after sessions, after marathon will be over, we will once again come up with 50-100 questions every subject. Don't worry, we have a wonderful plan for you guys. इस बार रैंक दिलवा के छोड़ेंगे. ओके, बताइए क्वेश्चन क्या होगा. ओके, डिमांड आ रही है वन मोर. ओके, आंसर बताइए पहले क्या आएगा. व्हाट वुड बी द आंसर फॉर दिस. यस, majority of you are saying C. Let me see, let me solve this, what we are getting here. Mind it, the length is L here. So minus P L cube upon 3 EI and plus PL by 4 L square upon 2 EI. I feel we would be taking 24 LCM. 4 to the 8. Minus 8 plus 3. PL cube. I feel 5 PL cube upon 24 EI would be the answer. Don't you feel guys? Have I done some mistake? B should be the answer as per my calculations. हाँ चलो, एक अभिनव सर एक करा देते हैं आपकी रिक्वेस्ट पर, ठीक है? हाँ जी सर,
धन्यवाद सर।
तो सर अब लास्ट क्वेश्चन के साथ खत्म करेंगे, फिर कल मिल रहे हैं गाइस। मैकेनिकल वाले याद रखें, कास्टिंग, वेल्डिंग, शीट मेटल ऑपरेशन। कल 3 टॉपिक, फिर बचे हुए टॉपिक वी विल बी डूइंग in the next lot. Okay, why I have done this? 20 hours is required for complete production. We cannot do that in 8 hour, 10 hour, 12 hours. Okay, so kal production and environment, these 2 things will go on. Mechanical and civil be ready.
सॉइल कौन बताएगा?
सोइल सर एक दिन बाद कल बताएंगे।
कल सॉइल है।
पर अच्छा अब तो कल हो गया सर, आज
production and
production।
environment।
ठीक है सर, मान गया मैं, टेक्निकली आप सही है।
Okay, do this. Deflection at B. If it is support A and C, so deflection at A and C will be 0. Okay. A is a support, and unless mentioned that support is sinking, so deflection at A is 0, deflection is C is 0. But B is not support. B is not support. Now, what is the deflection? Now, guys, if I do it, W Newton per, इसको हटाओ, W understood मानते हैं। This is 4A, and from here B, reaction will be coming upward RB. Reaction will be coming RB. Now here 2 C 2A, and of course the same reaction will be downward RB, and it is again W. Guys, suppose my 2 hands are like this. If they are going down now and it is still jointed, not like this, okay, or not like this. If they still are jointed, the deflection of both right and left hand are same at this point. I'm not saying at this point and this point, but when they are jointed, the both, if there is some load and going downward, then at this point now, this point deflection is same. This point I'm saying. Okay, if it's going down that and they still are jointed, of course the deflection will be same. Now deflection here will be here WL4, L is 4A की power 4 by ATI, and minus due to RB, it is RB into L cube. L is 4A whole cube by 3EI is equal to, due to this, it is RB into L cube, that is 2A का whole cube, RB into L cube upon 3EI, and due to WL4, W into 2A की power 4 upon ATI. Understood? From here, find the value of RB. From here, the RB value you are getting as कितना आ रहा है सर? 5WA by 4. 5WA by 4. Now deflection at B point, either you put here or here, RB value. Either you put here or here. Both are equal to na yaar. So either you put here or here. The deflection value is coming to be 16WA. Okay, that is option number. कौन सा है? Option number this. सर ये A और C तो सेम ही है. दिखाइए सर. A और C MSQ कर दिया?
नहीं सर, में मिसप्रिंट होगा.
मिसप्रिंट होगा. नहीं A में 3I है, इसमें EI है. सर आप ध्यान से नहीं है, अभी गलत है
थोड़ी सोल,
अभी एग्जाम में गलत हो जाता है आपका.
मैं दे ही नहीं रहा था
अभी फिर तभी -2/3 होता है.
सर कई साल हो गए एग्जाम दिए.
ओके, सो आइए सर, अब बच्चों को एक बार कल मैराथन लेना है, आपका भी मैराथन है.
हाँ. सो गाइस आज हम यही रोक रहे हैं आपकी रिक्वेस्ट पर, क्योंकि हमारे पास तो 20 क्वेश्चन हो रहा है और सर इनको यकीन नहीं हो रहा, तो एक बार दिखा देता हूं मैं
ही दिखा देता हूँ.
देख रहे हो, खत्म नहीं होने वाला था, कम से कम 1-1.5 घंटे होते.
20 से
टोटल सर, टोटल 19. देखो नंबरिंग देखो आप. Okay guys, so but don't worry, as we know you also have marathon tomorrow. We also have we would be sharing you this. Okay, and also guys, tomorrow we are meeting for production for mechanical. Tomorrow morning means today morning. And for environment for civil peoples, Richa ma'am would be taking environment for civil student. I'll be starting production for mechanical. And guys, I would be doing it from the basic. Everything we will be teaching you in a marathon way. And guys, we would be covering 3 topics tomorrow, for which the weightage is approximately 6 marks. Okay, because 2 marks for welding, 2 to 3 marks for casting, and 2 marks for sheet metal operation. 6 marks in one day. And the way I will be teaching you, you will be able to make each and every question. You can attend then you can find the difference. And guys, similarly, we would be having second day of production after 2-3 days. On weekend, we are having theory of machines, machine design I will be taking. And then sir, आप बता दीजिए आप क्या क्या
मेरे तो सॉइल है परसों, फिर सर्वे है. ओके. प्रैक्टिस चलने देंगे. ठीक है, ठीक.
हाँ, प्रैक्टिस चलेगा भैया, प्रैक्टिस चलेगा.
ओके गाइस, थैंक यू, गुड नाइट, टेक केयर. ओके, थैंक यू गाइस.